Hi, I'm Doyle Bishop with Tulsa Heaters Midstream. Today I want to talk to you about hot oil systems, and this is part two, one of my favorite topics. So one of the questions is why hot oil? Who came up with that idea? Why don't we just directly heat, right? We're trying to heat a process. We're taking hot oil, heating the oil, then taking that oil and using it to heat up another process fluid. One thought could be hey, why don't we just take the fire, the natural gas burning that we're doing, use it to heat up the process and skip the whole hot oil thing? I think it's a great question. So I think about in my life, here's a real practical example, and you've probably experienced this too if you've ever fried an egg, especially the first, dozen times that you do it. You're not really sure exactly how hot to make that frying pan. And if you've got a gas burner under it, you're really not sure how hot that frying pan actually is. So you crack an egg, and I've done this before, and you put it in and oh gosh, yeah, the egg cooked really fast. I got it off of there and it was kind of rubbery. It was a little tough. It was hotter really than that pan needed to be. If I had maybe controlled that temperature a little bit better, lower the temperature and keep it steady and cook that egg over 4 minutes instead of 30 seconds, I probably would have enjoyed it a whole lot more. That same analogy takes place in a process plant. There's certain processes that really need to be heated very accurately. You don't want to heat it with something that's way too hot only to find that you damage this process fluid in the heating process. So hot oil systems allow you to just dial in that temperature to exactly what you want to make sure you're not going to overheat that process. The systems are comprised of heaters and temperature control and fuel gas control and safety systems. There's a lot of equipment, a lot of control in there that allow you to get the exact temperature that you want besides just the heater or just the burner. The other thing that it can do is hey, I want to heat multiple things all at one time. So I can have this big heater, this big heat medium system, and I'm sending hot oil to exchanger number 1, exchanger number 2, and exchanger number 3. And I'm doing that all with one heat source, one burner management system, so your capital costs would be a lot better versus trying to heat all 3 of those with your own burner management system. And then the last thing, I can take this fired piece of equipment, which anytime you have a fire, there's a certain element of risk. I can take that piece of equipment and I can move it out away from everything and then send hot oil back and forth into my process plant. So reduces hazards as well. So let's talk about what are the major components of a hot oil system. This is kind of a cool graphic here. I like the graphic because it just shows you, hey, this hot oil just goes round and round and round in a circle and never gets off the merry-go-round. So I've got a heater in here. After I heat it, it goes to a user, which is an exchanger, and then it goes back to a pump skid, which provides the motive force to keep this merry-go-round going around and around. So let's look at, hey, here's a cool picture of what one actually looks like in real life. This is the expansion drum. These are the pumps here. There's 2 pumps, and then here's the motors for the pumps. And then I've got some valving in here as well. So the fluid actually comes in on this end of the skid and goes into the pumps, it comes through, and then actually goes out. I don't know if you can see all that with all those scribbles, but that's a pump skid. So let's look at it in a graphical way. Okay, the first thing, let's talk about our pumps. So you see I've got 2 pumps, so why 2? 2 pumps is because you want an install spare. For a 2-pump system, each pump can deliver 100% of the flow. So that means normally people will operate with one pump on and one pump off, just waiting for the call in case one of the pumps fails, and then it gets turned on, valves get opened up. What you don't see here is there's also some isolation valves in these lines that allow you to isolate that pump besides just the check valve. The check valve is there in case, oh, I forgot to isolate the pump's turned off, you don't have backflow through a pump spinning the impeller backwards and causing problems with your pump, actually unscrewing the impeller maybe in some cases. So the normal way is to isolate these valves to take this pump, or turn these valves off to isolate the pump to take it out of service, and you just operate with one pump. Depending on the system, if the flow is really, really high, you reach kind of the upper limit of an ANSI pump, and there might be a third pump. You could have 3 pumps. In that case, you have 3 pumps at 50% capacity, so that you would have 2 pumps on, 1 pump off in a 3-pump system. Coming into the pump, you've got a strainer, which is a nice thing to have, especially during startup. You're putting all this piping together. There could be field routing or field fabrication of piping spools that you could be making welds, putting the spools together. You could have bits of well metal, trash, all sorts of things could accidentally get into that piping system, and these strainers come in handy when you first start up to catch all that debris. A lot of times people would take the strainers out, take the straining part out after you start up and flow this thing for a few days so that you don't continue to burn that horsepower of pressure drop through the strainer, but they're great for startup. The other thing that typically is in a system is a filter. This particular filter is shown in what we call a parallel flow, in that a slipstream comes off of this line via this valve. We use this valve to create some pressure drop and force fluid through the filter and back down, and it continually filters day after day, 24 hours a day. Normally a filter is sized for maybe 5 to 10% of the overall flow. Doesn't need to be full flow. We call it a slipstream filter. So then it goes to the heater, and then from the heater it goes to the exchanger, and then from the exchanger or users it goes back to the pump skid, and on the way it passes by this expansion tank. And we're going to talk about the expansion tank in a little more detail. Typically, expansion tank has a blanket gas system over it. It's got a level gauge. You have some normal operating level in that expansion tank at all times. This is the major components of what's on a pump skid. Let's talk a little bit in more detail about the expansion tank itself. So you've bought a heat medium system or a hot oil system. You've got this pump skid, you've got a heater, you've got it all connected up to the exchangers or the users. Now it comes time to fill it up. So you have a tanker truck come in with maybe Therminol 55 or Chemtherm 550, and you start filling it. One of the things you say is, okay, how much do I put in? Well, one of the things that you have to do is you want to get all the air out of the system. It's almost impossible to get it all out until you start running the pumps a little bit. But let's say you got the tanker system hooked up, the tanker truck is hooked up, you're filling it up, got a little pump in here off the truck, and typically you want to fill it up to this low level. And normally you're filling it up, maybe the temperature of the fluid 70 degrees, so it's obviously a lot lower in temperature than what it's ultimately going to see. So you fill it up to the low level. You know, there's some vents in these lines. I'm just going to show a vent here. You're going to vent the tank first as you fill it, and then there's lines that come in out of this. I'll show it really high up in a pipe rack. You probably have a vent up in a pipe rack at a high elevation that you're going to vent there as you fill this system up. Once you get it filled, then you're going to turn the pumps on, and start getting the air out. Well, one of the ways to get the air out is to have it disengage in the expansion tank itself. So you can see this color combination of valves that I've got shown here. This color combination shows how it would be set up during what we call the boil out, or get the air out, get the water out of the oil stage of the startup. And so it's set up such that all the flow goes up this side and down this side, and there's no flow going through this valve during that time. So you're trying to get the air out. You'd leave this vent open to let air and steam come out of there during the boil out period. And ostensibly, you're going to heat it up so the level's going to rise in this tank a little bit, because the fluid itself is going to get heated, it's going to expand some. Once you get that done, then you're going to change this valving setup. This valve now is going to be full open during normal operation. But you also leave these guys open, full open, so the fluid can actually expand up in the tank. So let's talk about what's pushing down on that fluid. We've got blanket gas on this fluid that's coming in, and typically it's natural gas, and it's regulated at 15 pounds. So under normal operation, the pressure of this tank is going to be somewhere between 15 and 30 psig, because I've got a relief regulator that lets gas out if the pressure gets too high. So you can see that, hey, I've got 15 and 30, so these regulators allow this level in the tank to go up and down and stay in between 15 and 30 pounds. We like the blanket, and Chemtherm and Therminol, they like blanket over this fluid because they want to minimize the reaction of oxygen with the surface of that fluid. And so you can use an inert gas like nitrogen or methane to get the oxygen out of this tank. There's ways to do that during startup. I'm not going to go through all that, but that's the basis of a hot oil system. So I'm going to give you one takeaway here. The takeaway on this hot oil system, or the pump skid for sure, is don't scrimp. And where you can scrimp on this, one would be the pump, is to say I'm going to exactly size the pump for whatever my ProMax system says I need for thermal fluid flow. That would be a mistake. Put some extra size on that pump. I always say you never get fired for making a piece of equipment slightly too big, but if you make it slightly too small, your future might be in jeopardy. So don't scrimp, make the pump a little bit bigger than it needs to be. And then also on this expansion drum, don't scrimp on it. You don't want to have an expansion drum where you find yourself, oh my gosh, I've got more expansion than I can contain in this tank. Just make the tank a little bit bigger as well.